Hey guys, in this video we're talking about quadratic functions and how to draft them using the vertex, the x, and the y-intercept. Let's go. Hey guys, and welcome back to your channel. If you have not done so already, go ahead and subscribe to the channel so you can get more content like this. Today we are going to be focusing on quadratic functions and how to draft them. We're going to use the vertex and the x and y-intercept to do so. And so the first thing we need to talk about here is the quadratic itself. So a quadratic function is a function that's written in the form of f of x equals to ax squared plus bx plus c. Or you can also write it as f of x equals to a in parentheses x minus h squared plus k, where in both of those cases, a should be different from 0. The first form here is the general form, and the second one here is the standard form. If you want to know more about how to go from the general form to a standard form, go ahead and check out note 14, where I talk a little bit about how to complete the square. Alright, so looking at the standard form here on the right, the standard form is often the preferred form because you can read off important information about the function directly from the expression. For instance, in this case here, our vertex is going to be the point of coordinate hk, and you can read it off directly from the expression. Also, as every quadratic is also a parabola, the draft of this function is going to have an axis of symmetry. And in this case, the axis of symmetry is going to be the vertical line x equals h. Let me give you an example. So if I give you the function f of x equals to 2, in parentheses x plus 1 squared plus 1, then you can read up the vertex directly from this expression. It's going to be the point P of coordinate -1, 1. Notice that in the standard form, what we have in the parentheses is x minus h. So when you're reading off the value for h, you should be looking at the opposite of the number next to x here. And that's why we have -1 here. Furthermore, our y-intercept for this function is going to be the point where the function meets with the y-axis. So the x-coordinate is going to be 0. And so we can find f of 0 to figure out what our y-coordinate is going to be. And so we're going to have f of 0 equals to 2, in parentheses 0 plus 1 squared plus 1. And that should give us 2 times 1 plus 1, which gives us 3. On the other hand, our x-intercept is going to be the place where the draft of the function meets with the x-axis, which means that our y-coordinate should be 0. And if you do y, which is f of x, equals to 0, you're going to get 2, in parentheses x plus 1 squared plus 1 equals to 0. And so solving that would give you x plus 1 squared equals to -1 over 2. Now, if you take the square root on both sides here, you will notice that you have a minus inside the square root, which means that you do not have any real solution here. So you can stop here and say that there's no x-intercept, at least no real x-intercept. And so once you figure out the vertex and the intercepts, you can go ahead and figure out the draft for the function. Now, a small parenthesis here, the function f of x here is a function that's coming from the parent function x squared. So you could also just figure out how to draft this function by using transformation. And we talked about that in my note 28 and 29. So check those out if you want to know how to draft this function using transformation alone and not vertex. Now for the draft of f of x here, I'm going to go ahead and draw my plane here. So this is going to be the xy plane. And once I'm done with that, I'm going to go ahead and plug in my vertex and my y-intercept. So we're going to have the vertex here at -1, 1. And also, we're going to have the y-intercept right here at 0, 3. Now, one thing you should know about the vertex is that it always represents either the minimum or the maximum point of the function. So in this case, since the y-intercept is above the vertex has no choice but to be a minimum point for the function. So we're going to have a minimum curve like here to give us a sense of the general shape of the function. Other than that, it's also important to know that if the coefficient a is positive, then your function will be opening up, and if the coefficient a is negative, the function will be opening down. So in this case, our coefficient a is equal to 2, which means it's positive, which means our function should be opening up. So those are just different ways you can deduce the general shape of your function, or whether your function opens up or opens down. And so once you have that figured out, you can go ahead and just draw a parabola here, connecting those 2 points and keeping in mind the general shape of your parabola, and then you'll be done. And just so we don't miss anything here, I'm just going to go ahead and show you what the axis of symmetry looks like here. So it's going to be the line x equals -1. And as you can see, if you look at this axis as a mirror, you can see that the graph is reflecting perfectly through it. Okay, now we're done. So let's see how you would draft this quadratic if you were given a general form instead of a standard form, without having to complete the square. If you have the general form f of x equals to ax squared plus bx plus c, then you should know that the x coordinate of your vertex is going to be equal to -b over 2a. And so since your x value is equal to that, your y value is simply going to be f of -b over 2a. And as usual, your axis of symmetry here is going to be x equals to -b over 2a, because the axis of symmetry is always going to be just x equal to the value of the x coordinate of the vertex. Okay, so let's see an example here. So if I give you the function g of x equals to -x squared minus 4x plus 5, your vertex is going to have for x coordinate -b over 2a, which in this case is going to be minus 4 divided by 2 times -1. And so on top, you're going to have minus 4 giving you plus 4 divided by -2 on the bottom. So that should be equal to -2. And so now to find the y coordinate of our vertex, you can go ahead and plug -2 into the function. So you can have y equals to g of -2, which is equal to -2 in parentheses squared minus 4 in parentheses -2 plus 5. And so that should give you -4 plus 8 plus 5, which equals to 9. And as usual, your y-intercept in this case is going to be the point of coordinate x equals 0. And so if you plug 0 into your function, you're going to get the constant c at the end. And so you're going to have here y equals to 5. And for the x-intercept, you need your y coordinate to be 0. And so therefore, you need to set the function equal to 0. And so you're going to have -x squared minus 4x plus 5 equals to 0, which should give you x equals to 1 and x equals to -5. All right, so once you figure out the vertex and the intercept, you can go ahead and plug them all on your plane in order to draft your function. So I'm going to have the vertex here, the point of coordinate -2, 9, and I'm also going to have the y-intercept here, the point of coordinate 0, 5. Finally, I can plug my x-intercept just for kicks. So I'm going to have the first one here at -5, 0, and the other one here at 1, 0. So again, if you look at the coefficient a, it happens to be negative, which means that our function will be opening down. Or, if you notice, our vertex is always going to be either the mean or the max. And in this case, since it is above all the other points, it has to be the maximum. And so at the vertex here, our function should be opening down. Okay, so once you figure out the general shape of your function, you can go ahead and connect all these points, keeping that in mind. And so you're going to have a parabola opening down like this. And just for fun here, I'm just going to go ahead and show you what the axis of symmetry look like. It's going to be this vertical line going through -2. And so with that, I am done. And so next time, I'm going to show you how to draft polynomial functions. As always, if you like a PDF copy of this note, check out the description below. If you like the way I break down the material, give me a thumbs up, and I will see you next time. Bye-bye.